Hello everyone and Assalamu alaikum. This is Introduction to Psychology Part 1 PSY 312 by Dear Knowledge. Okay, we have successfully completed the lesson 1 of the chapter 4, in which we discussed about the characteristic and major functions of different sensations. So if you haven't watched those videos, I have given a link in description. Go ahead, click on those links and watch those videos. So in this video, we'll start the lesson 2 of the chapter 4 of which is sensation. So the lesson 2 is about vision, structure and functions of the eye. So in this video, we'll start with the part 1, which is about the visual system, in which we'll discuss the nature of light and the properties of light. So let's start with our today's video. So today's video is about vision, which is your human camera. So we see a world that is filled with shapes and sizes, stationary, moving, black and white, colored, and so on. So human beings are basically visual organisms and rely heavily on their vision or sense of sight. So the sense organ for vision is the eye, and the eye contains sensory receptors which are sensitive to the physical energy or stimulus, light. So to understand our sense of vision, we need to discuss the basic characteristics of the light. So in order to make this lecture more clear and easy, I have included some terms which I'm going to be using in my lecture. The first one is electromagnetic radiation and the second one is the wavelength. So I've included the definition here, but I've used these terms in my lecture, so you will better be able to understand what I'm talking about. So the first one is about the electromagnetic radiation. This is basically a form of energy including electricity, radio waves, and X-rays, of which visible light is a part. And wavelength is basically the frequency of light waves which determine the color we see. So in 1950, psychologist George Wald wrote an important paper comparing the eye to a camera. And this is still a good anatomy today. Both the eye and a camera are instruments that use a lens to focus light onto a light-sensitive surface on which the visual image is registered. And the gross anatomy of the human eye, as you can see here, makes the resemblance of a camera very apparent. So this efficient instrument transduces the physical properties of light into elaborately coded neural messages. So we'll start with the light. Light is basically one small part of the form of energy known as electromagnetic radiation, which also includes radio waves and X-rays, and only a small portion of this radiation is visible, and that is our senses can transduce only a small part of it. And we can best think of light as being composed of waves that vary in frequency and intensity. So these two properties of light waves provide us with most of our information about vision. So if you talk about the nature of light, as we have already discussed, that light is just one of many different kinds of electromagnetic energy that travels in the form of waves. But other forms of electromagnetic energy include X-rays, the microwaves you use to bake a potato, and the ultraviolet rays that give you a sunburn. The various types of electromagnetic energy differ in wavelength, which is the distance from one peak to another. And in this picture you can see that this picture shows the spectrum of different form of magnetic energy, and humans are capable of visually detecting only a portion of the electromagnetic energy range. And you might have noticed that the visible portion of the electromagnetic energy spectrum can be further divided into different wavelengths, as you can see in this picture. So different wavelengths of visible light correspond to our psychological perception of different colors. So let's start with the nature of light. As we all know, and we cannot see without light. And light is a form of electromagnetic energy that travels as waves And there are many different types of electromagnetic waves, like X-rays, radio waves, ultraviolet rays, and so on. So together these waves form the electromagnetic spectrum. So waves of light are like ripples created when a stone is thrown into the water. And here you can see that light waves have basically two physical properties: the wavelength, that refers to the distance from the peak of one wave to other, or the amplitude, which is the height of the light wave and determines the intensity. So wavelength, which refers to the distance from one wave, from the peak of one wave to the other. Changes in wavelength are psychologically experienced as changes in color. So human beings can only see wavelengths between 400 and 700 nanometers, and these wavelengths are experienced as colors ranging from violet to red, and this is only a small portion of the total range of wavelengths. And there are other animals which have different capabilities and might be living in different visual worlds. For example, butterflies can see the ultraviolet light as they have those receptors, and some fish can see in infrared light. So though the other wavelengths also enter their eyes, but we cannot see them, or we cannot sense them. So amplitude is basically the height of a light wave and determine the intensity, which corresponds to the amount of the light falling on an object. And intensity is psychologically experienced as brightness. So the intensity of light waves largely determines the brightness of the visual sensation. The light reflected by, for example, an apple that is lighted by a single candle is low in intensity. So we see the red of the apple as a dim rather than a bright sensation. And the wavelength of light largely determines the color that we see. So that is, light wave of different wavelengths are seen as different colors, but most light waves are not made up of a single wavelength and are therefore not seen as a pure color. Rather, they are made up of light waves of more than one wavelength. So the more color is composed of multiple wavelengths, the less saturated the color is said to be, or you can say the less pure color is said to be. So the relationship between the physical properties of light and what is seen is not always simple, however, but our sense of sight is dependent on light. And but for us to see the visual input, light is to be converted to neural impulse that are sent to the brain, and it is in the eye that this transformation occurs. And light usually comes from a source such as the sunlight or a tube light, and enters the eye after bouncing off the object. So this was today's video. If your concept is clear, you can like the video. If not, you can ask us in the comment section and we will be happy to help you out. Plus, if you're new to this channel, you can subscribe, you can click on the bell icon so you'll never ever miss any notification from Dear Knowledge. Plus, you can share the link of this video and this channel with your family members and friends, because sharing is caring. Until then, Allah Hafiz.